In this example here, we will be looking at graphs of sine and cos, particularly for the graph of cos, and we are going to sketch this graph with a domain from negative pi and 4, not including, to 5 pi and 4, including. So just before we get started here, that curved bracket will indicate that we have an open circle at that particular endpoint, and the square bracket will indicate that we have a closed circle at 5 pi on 4. Let's start off with the amplitude, which is 2, referring to the front of the cos, and we'll find our period, which is 2 pi on n. Our n value here is 2, so 2 pi on n is equal to 2 pi on 2, which is pi. We'll also find our range. But perhaps let's find our range at the end, once we finish sketching our entire graph, just in case if the graph doesn't complete an entire cycle. Let's draw in our basic sketch here. We start with a mean line of 0 because we have not added any value at the end here, or subtracted any value. And our amplitude goes up by 2 and down by 2. Let's figure out our period here. Start at a default of 0 so that we end up at pi. And we will break this up into our quarter increments. So multiplying by half, multiplying by 1/2 again, and multiplying by 3 to get 3/4 of the way. For our graph of cos, we start at the top for a positive cos, and we'll go down and back up again. So 1, 2, 3, 4. Remember, we only need to focus on the first 2 points to figure out the rest of our pattern, because we know it joins by this first increment. So going down to our good copy down at the bottom here, I'll draw our first increment in black, and if we extend the graph, we'll draw it in a different color. Our first point here is 0, 2, starting at the top. Our second point is at 0 pi on 4 and 0. And this is our first increment here. If we continue this graph, we will go to the next point, which is down below, and I might just change colors here. So you can see that the pattern just continues for every quarter increment that we implement, like so. So extend this graph up until 5 pi on 4, which we do have a solid circle or a closed circle because we have a square bracket. Similarly, if we extend to the left here to get to our left endpoint, we get to pi on 4, but for this point, we have an open circle. Once we've put in every coordinate and sketched up the smooth curve, we can put in our coordinates. Endpoints first. Let's do our endpoints first. Then our x-intercept, pi on 4, 3 pi on 4, and our y-intercept, which is 0, 2.